Good day, class. Welcome to the E-series of digital image processing course. This is the first lecture, and in the first lecture we will focus on some definition and introduction materials that you have to know before we start the journey of this course. Now we start by defining what is an image and what is a digital image. An image is a two-dimensional function of f of x and y, where x and y are called the spatial or the plane coordinates. So as you can see, an image is represented as a matrix from mathematical point of view. Now the amplitude of f at any point of x and y is called the intensity of the image at that level. Now, if at a given x and y, this amplitude, this intensity value is finite and discrete quantity, then we call it the whole fm x and y as a digital image. So a digital image is composed of a finite number of elements called pixels, and each of these pixels has a particular location and intensity or value. Now, in this slide, you see the first digital photograph ever, which has been produced in 1957 by scanning an image. So, as Gonzalez and Woods have reported in their books, this is the first digital photograph ever. Now, let's look at this example that we have. It is a two-dimensional grayscale image, and each pixel is represented by 8 bits, which means that the pixel intensity value changes between 0 and 255. 0 regards to the black and 255 regards to white. Now let's look at the first and the last pixels. At the location 101, we have the intensity value of 103, and the last location, the intensity value is 88. Now here you can see a subsection, a sub-image of the original image, and 6x6 sub-image, and you can see the pixel intensity values. These values, as you can see, are finite and they are discrete values. Now, one very important thing that we have to remember is that digitization implies that a digital image is an approximation of a real sense. Later in the next lecture, we will talk a little bit about sampling and quantization. So what we see that we have a continuum, a continuous form of a signal, and we are trying to digitize it and approximate it. Of course, in the scenes that you see in the cinema and TVs, we have millions of pixels, so what we see looks like a continuous form, which is not. Now, what is digital image processing? Digital image processing is any type of process that we do on a digital image. Like we have a color image, we convert it to the grayscale, or we enhance its illumination, or we are using an averaging matrix, we are using an averaging filter in order to make our image blur, or we are using Laplacian to sharpen our image. We are extracting the edges, we are converting the image into the black and white, or even we can stick into the color domain and let's say enhance the color of this image. So all these examples that you see in these slides are an digital image processing. Now let's see what are the sources of digital images. The principal source for the image is the electromagnetic energy spectrum. And the spectrum bands are grouped according to the energy per photon, ranging from the gamma ray to the radio waves. And gamma ray has the high frequency, low wavelength, and the radio waves has the lowest energy and lowest frequency, and they have the highest wavelength. And from this graph in the slide, you can actually see the figures which you are familiar with from the physics course in college. Now, let's talk a little bit about the gamma ray. So we will go through each of these bandwidths, we give some examples about them, though we will not focus on many of them within this course. Gamma ray can be used in astronomy and in medical imaging. As you can see, for instance, we have a picture of gamma ray imaging in the Cherenkov telescope, or the ones which has been used in some medical applications. Now we can continue to the X-ray. X-ray should be one of the bandwidth which we are very familiar. If you had a broken bones, you usually take a photo by using these X-rays and cameras in order to find out what is going on with the broken bones. So it's in medical imaging, it's used quite a lot. In electrical and electronic engineering, we use it in order to find out whether we have a discontinuity at some part of the board or not, and also definitely we will use it in astronomy. Now in the ultraviolet, we can take pictures, but within this bandwidth, as you can see here, there is a photo of the core which has been taken. And some scientists and experts, when they look at these photos, they can interpret them and find out whether we have any problem in that situation or not. Now, the bandwidth that we will focus in this course is the visible light. All the photos that you have taken, as you can see in the slides, you put them in your face or in your instrument, all of them are in the visible light. And in this course, digital image processing, we will see how we can enhance or how we can improve the quality of this image in this bandwidth. The next bandwidth is the infrared, and as infrared's nature is famous, it is used for thermal imaging. We can use it in order to, let's say, detect human being, because our body temperature is not the same as the background temperature. And definitely we can use it in some astronomy applications, as you can see in this picture. Now, microwaves are used in order to generate some maps. The basic fundamental rule of the synthetic aperture radar systems is based on these microwaves. They employ a tube into the airplane, and it flies over a surface and it grabs lots of photos, and they generate a map, a 3D map based on this information. And in the radio waves, I think the best example that you may remember is MRI imaging, which is used in order to make a photo and set this image of the sizes of our brain. Now, here in this slide, we see an example showing imaging in all of the bands, taken from the Gonzalez Woods book, a picture from NASA of the same sense, by having grabbed by different image acquisition tools with different bandwidths. As you can see, each of them are representing different information, where scientists, astronauts are looking at them, they can interpret them, and they can grab and find out more information, which maybe we cannot. Now, electromagnetic spectrum is not the only source that we use in order to produce images. Ultrasound imaging is one of the other ways that we use in order to make an image. Ultrasonic imaging is a cycle sound pressure waves with frequency which is much higher than the upper limit of the frequency that we can hear. And the most well-known one is the sonography, to produce the picture of the baby in the human wombs. And as you can see in the slide, we see the different range of ultrasonic spectrum from the infrasound, acoustic to ultrasonic. Now, in this course, we will focus on image processing. Let's see what is the quantum form of image processing to computer vision, and how we can break it into the several levels. We actually can break it into 3 levels: low level, mid level, and high level processes. Low level is the thing that we will focus a lot in this course, and in the low level processes, in the process we have the input to be an image, the output to be an image, and what we do, we are enhancing the quality of this image. Let's say we are removing the noise. In the mid level, we give this enhanced image as an input, and what we get as an output is attribute, like segmentation, object detection, face detection. We give this photo and it detects where the face is. And the high level, we give these attributes and we do the understanding, like a face recognition system or information retrieval system. Now let's slightly talk a little bit about image acquisition. The images are generated by combination of an illumination sources and a reflection or absorptions of energy from the source. For instance, if we are absorbing all the illumination, we have black. Or if we are reflecting all the light, we will have white. There are some imaging sensors which are used in order to convert this illumination energy into the voltage waveform. And these voltages are quantized in order to tell us the level of the tones that we have. Now, in general, we have three types of image sensors: single sensor, line sensor, and array sensor. Array sensors are used in the cameras that we have. Series of them, lots of them together. At one instant, we grab them, amount of the light which has been reflected from the objects. So today we talk about what is a digital image, what is digital image processing. We gave some examples of digital image processing. We talk about image acquisitions, and as I said, it was a very introductory materials that we had in the first lecture. We actually will start to talk about the key stages in digital image processing, which is sampling and quantization, and we will talk about interpolation in next lecture. I want you to go through the material which are provided on the web, and see you in the next lecture. Thank you.